So I'm back. I've got another exercise from the cookbook exercises. Now let's see what was happening here. So the management of a large restaurant claims that waiters and waitresses average $75 per day. I have no idea what people average these days. It's been so long since I've worked in the restaurant industry. But that's what the problem says. The staff felt the figure was too high, and they went out and collected 270 data points. So N is 270. They found the sample mean was 72.33 and the sample standard deviation was 15.48. Um, so let's see what we're gonna do. What conditions do we need to see? Well, it looks like it's a random sample. They don't say this is a random sample, so that's an issue. Um, it would have been nice to know that. So what you can say is, well, this doesn't seem to be a random sample, but we're going to go with it anyway. So you make those comments. Um, then we're gonna let's see. So then I don't know I don't know anything about the distribution of tips. So I don't know if it's normal, symmetric, or skewed. And then what else don't I know? But I do see, and I don't know the population standard deviation, right? But I do have a sample, a large sample. We have that large sample of 270 data points. So the central limit theorem to work, we could have a random sample. It's got to be quantitative variables, um, and we have to have and in this case, since we don't know the shape of the population and we don't know the population standard deviation, our sample size has to be bigger than 30, and sure enough, it is. So we're good to go with using a one sample t-test. So now we got to figure out what the claim is. Well, it's kind of right here. I highlighted this in green. Do I still have the little highlighter? See, it says they claim the waitresses average $75 a day per employee in tips. So that's the claim. Now let's write our HO and H1. So let's see. HO, the mean, notice I'm using mu because it's the mean, is 75 or more, right? So that's what the management's doing. So there's the claim. I think. I mean, that's what I would do. I mean, you could certainly make H1 be the claim and do it a little bit differently. I mean, how you do it isn't, it's how you interpret it that is. But I think the way this problem is worded, it's to me it makes sense to make HO be the claim. So then H1 or HA, the staff felt it was too high, so that makes it sound like they think it's lower than 75. So I'll try a left-tailed test again, and I also notice that the sample mean is less than 75, so that would support a left-tailed test. Now we're going to run the test statistic, and you can certainly calculate a t-score, and that's not impossibly hard. But I'm also going to point you towards this Rossman chance calculator. And the beautiful thing about this Rossman chance calculator is you just want to, here, let me get a pointer. Once you go there, select one mean, because this is about means. You got to type in your sample results, the sample size, the sample mean, and the sample standard deviation. Click calculate. You check tested significance, and then you got to see how we did HO and H1 first. That makes our work a lot easier. So you type in the 75 there, it'll automatically populate here. And because this is a left-tailed test, you got to click on this so you get a left-tailed. People get this wrong because they forget to change that. And then you click calculate, and what do we get? Well, we get there's our t-score. That's the test statistic. So if you use this on a quiz situation, I would like you to, I mean, for a discussion forum post, paste this in. For a test situation, you don't need to give me this picture. I do need to know the test statistic, and I do need to know the p-value. Um, okay, I caution you if you're going to use Rossman chance on MyOpen Math. Rossman chance only gives us 2 decimal points. Sometimes MyOpen Math wants 3, so use a different calculator. Just don't worry about getting that part wrong. It'll usually do the p-value right. And then, so let's see. Now we're going to make a decision about HO. Well, if we're testing at the 1% level, is this number less than 1%? If alpha, let's see. If come on, Dan. I want a black pen. Here we go. If alpha, the level of significance is 0.01, and our p-value is smaller than that, right? Because 0.0025 is a whole lot less than 0.01, or 0.25% is less than 1%. So because that's smaller, it's unlikely to happen. You see the small area? It's way more than 1, 2, and it's almost 3 standard deviations away from the mean. So, I mean, we didn't do a critical value for this, but because the p-value is so small, we know it's probably an outlier, unusual. So we're going to say reject HO. Nice if I could spell. And then we're going to put it in context. So I made HO the claim. So again, null hypothesis. We reject the null hypothesis. We're going to say there's enough data to justify the rejection of the claim that the average amount of oh Dan, let's see, just a minute. The average amount of tips per employee. This is why it's nice to be able to copy paste this stuff in. Employee per day. Excuse my spelling. When you see me start writing that way, it means I'm not spelling it right, so I just kind of fluff it. Amount of employees per day. So there's enough data to justify the rejection claim that the average amount of tips per employee per day is $75. Okay. Alrighty, let's do proportions next.